Hi guys, we're going to continue here with graphing square root functions. This is chapter 10. So let's take a look at that. Alrighty. So a square root function is a function that contains a square root with the independent variable in the radicand. Remember, the radicand is what we're looking at right here, okay, underneath the square root. The parent function of the family of square root functions is just the square root of x. So remember, that parent function is the most basic type. The domain for this particular function is f of x, or sorry, f is x is greater than or equal to 0, and the range y is greater than or equal to 0. So if we take a look at that square root function, which we see right here, you can see it almost looks like half of a sideways parabola. So that's what we're looking at. This is the basic type of square root graph, and every type of square root graph is going to look like that. So let's describe the domain of our square root graph that we see right here. So remember, the domain is the possible set of x values that this graph could take on. So if we're trying to describe this domain here, we could see that it's starting at 5 and then it's going off to the right. So your domain here would be x is greater than or equal to 5. Okay? It doesn't ask for the range here, but if it did, your range would be y is greater than or equal to 0, because all of your y values are above that x-axis. They never get below 0 into anything in this range here. Let's graph the square root of x plus 3, and let's describe the range. So if I'm trying to graph this function, and I want to see what that graph is going to look like, let me see if I can get my pen to work here. There we go. So that's the graph of the function. And again, guys, you could be using Desmos to do this. And I'll show you at the end of the video how to plug this stuff into Desmos. But that's the graph of our function. Okay, if we wanted to make some x and y values here, we know that we're starting, no negative value is going to work. Okay, and let's talk about that for a second. Say I tried to plug in a -1 here. Let me get my pen back up. Say I tried to plug in a -1. Why doesn't the graph exist there? Because the square root of -1 is not a real number. Okay, that's why we can only use values starting at 0 and above. Okay, and if I wanted to, all right, if I plugged in 0, square root of 0 is 0, plus 3 is 3. And if I wanted to, let's do an easy one, like plugging in 4. The square root of 4 is 2. 2 plus 3 is 5. So I know that's why I have the point 4, 5 right there. Okay, and I could plug in the values of 1, 2, and 3 if I wanted to. Let's talk about the range, all right? Where does this exist in terms of the y values? Well, you'll notice it never gets below a value of 3, which is my y-intercept. So your range here would be y is greater than or equal to 3. All right? Your domain doesn't ask you for it, but what x values could it take on? X is greater than or equal to 0. So it's important, guys, that you're understanding the whole range and domain aspect, which is what we've seen before. Okay, think about range. Where does this exist in terms of the y values? Domain, where does it exist in terms of the x values? Okay, if I wanted to, you could do these on your own, but you'd have to go ahead, graph them. I would graph them in Desmos and see where they end up. If we wanted to take a look at some of these ones here and take a look at the graphs, okay, here are the graphs of the functions. And if you were asked to describe the range of these functions here, here would be y is greater than or equal to -4. Here it would be y is greater than or equal to 0. Now your domain here would be x is greater than or equal to 5. So let's just think about that for a second. Your domain is x is greater than or equal to -5. And here your range, even though it's a different, more steep curve, is still just y is greater than or equal to 0. So again, you're thinking, where does the y exist and where does the x exist? Let's talk about translations. We've seen this in other things. We see it again. Just like it was when we were dealing with absolute value, when you have that thing happening on the inside, okay, like inside the square root, that's your horizontal translation, meaning it's your left, right. But you'll notice it goes in the opposite direction as you would think. So when we have a -2 in there, it's actually going to move it 2 to the right. And when we have a +3, it's actually going to move it 2 to the left. Outside of the square root is your vertical translation. That's your up-down movement. And that moves exactly as you would see it, you would think it would do. Reflections are either inside or outside. That's your negatives. That's going to reflect the graph, meaning it's going to flip it. Your horizontal shrink and stretches, that's the numbers that are next to the x. So if we see them there, okay, that's your shrink and stretch on the inside. And then we could also have vertical stretches or shrinks, and that's on the outside of the square root there. So let's take a look at this, okay? We've graphed the parent function down below. Let's graph our new function using Desmos. Nope, we don't want to graph it. Oh, oopsies. Well, this graph doesn't want to show up, but we could still describe the graph as compared. We could see what two things are happening here. Okay, we can see we've got this on the outside, and then we've got this negative -2 on the inside. So let's go back to our table that we just saw. We know that a negative on the outside is right here. That's going to be a reflection in the x-axis. So we have a reflection. Oops, I don't want to be in highlighter. Reflection in the x-axis. Then we also have this -2 here. If we go back to our table, that's a -2 on the inside. That's going to be a horizontal translation right 2. Now would be a good time. Let's go into Desmos and let's actually graph this so we could see. We've got negative and then square root of x -2. So let's graph our parent function first, which is the square root of x. Oops. Gonna work there. Gotta move this thing. There we go. So we've got square root of x as our parent function, which is right there. And then we had negative square root of x -2 as our new function. So you can see, guys, this was a flip over the x-axis, reflection over the x-axis, and it moved to the right 2 units. So now we can see our two graphs together on the same coordinate plane. Let's go back into our examples. Okay, so if we wanted to take a look at some of these other ones, here would be our new graphs. And again, just make sure whenever you're asked to describe them, you want to, I'm going to go back to this table. This table is key. Maybe take a picture of it. Okay, this goes through all the different things that could happen. So this is what you want to refer to. That way you're using the right vocabulary when you're describing all the different types of translations that you could see. Okay, let's take a look at this one. A lot happening here. We've got -2. We've got square root of x -3, -2, and we want to compare it to the parent function there. So let's go one step at a time here because there's 4 things that are actually happening here. All right. And again, we could use Desmos to get this graph. So let's deal with this and this first. So we've got that negative and then we've got that 2. Let's go back to our slide. We've got that negative on the outside. So I know that's going to be reflection in the x-axis. And I've got a 2 on the outside as well. So I know it's going to be a vertical stretch by a factor of 2. So let's go with both of those things first. So we have a reflection. And then we have a vertical stretch by 2. Let's deal with the inside part right here. That's my left-right movement, and it goes the opposite. So I know it's going to be right 3. And then I know my -2 down there is going to be down 2. And I can see that if I look at the graph here. Okay, reflection, yes. Right 3, yes. Down 2, yes. And this graph is a vertical stretch if I compared it to the original graph there. Same idea here, okay? If we think about this is going to be a vertical shrink by 1/2, left 4 and up 1. So vertical shrink, meaning it's kind of compressed down, all right? Left 4 units, yes. Oopsies. And then up 1 unit, and we're good there. We're going to hold off on the example here with the word problem. I don't think we need to worry about that one. So again, key things here as you're doing this unit and this lesson, all right, make sure that you know your translations and you're good with the different types of vocabulary here. And again, make sure that you're just using Desmos as you're doing that. To get those square roots, you just got to click on the little square root tab there. And again, we could see different types of things. Like if I wanted to do 0.5 and then a square root of, let's put a 2x in here. And then let's do +2 and then -5 on the end. You can see all the different things that are happening here with a graph such as that. So use Desmos to help with the graphs, and then make sure you're comfortable with the vocabulary that you're dealing with in this unit. That's all. Good luck. I think it's a pretty straightforward unit, and you should be good to go.